Okay, ladies and gentlemen, today we are going to look at cracking of hydrocarbons. So, as we should already know from our previous work, a hydrocarbon is a substance or a compound which only contains hydrogen and carbon. Okay, and we have looked at the fact that hydrocarbons, the ones we've particularly been focusing on so far, are called the alkanes, can be obtained from the fractional distillation of crude oil. Okay, so we get our alkanes out of crude oil, and we've looked at that process of fractional distillation, which, remember, is a process by which we can separate the mixture of hydrocarbons, which is in crude oil, into groups of molecules which all contain the similar boiling point. They have similar numbers of carbons and they have a similar boiling point. Okay. All right, the graph below shows the varying different amounts of hydrocarbons with different lengths of carbon chains. Okay, so 1 means that it's got 1 carbon. Okay, 4 means it's got 4 carbons, and so on, up to greater than 24 carbons. Okay, so as we go from left to right along the x-axis, the chains are becoming longer. Okay. The blue bars represent the percentage that is actually found in crude oil. Okay. And the demand is how much we need or how much we want. Okay, so when we're looking at the demand, it's basically how useful is it. Okay, so your first task in your Google Doc is to write down 5 facts about this graph. Okay, so these can be simple statements. 5 things that you notice, 5 bits of information that you can get from this graph. Pause the video now and do those 5 points. Okay, and your second task is to use those 5 points, okay, to come up with 1 or 2 conclusions that you can make from this graph. So the difference there is the 5 facts are just 5 things that you can see about the graph. The 1 or 2 conclusions is, what does this tell you? What things can you then use those facts to conclude about the graph? Okay, so pause the video now. You can ignore this part at the top where it says 3 marks. That's the way I would have done it if we were discussing this in a lesson, but obviously we are distance learning at the moment. Pause the video now and do those 2 conclusions. Okay, so what we should have been able to see from the graph is that crude oil contains more of the long chain fractions or the heavier fractions, okay, because there's more atoms in them. If they're longer, they will also be heavier. Okay, so crude oil contains more of the long chain fractions than it does of the lighter short chain fractions. Okay. We can also see from the graph that the short chains are more useful and therefore we want more of them. The demand for them is higher. Okay. The reason that they're more useful is that they're much more flammable, therefore they're more easily burnt to produce energy, which is what we generally use the alkanes for. Okay. Now, to think about how we solve this problem, you could think about a piece of string. Okay, imagine that I have got a long piece of string, but I don't want a long piece of string. I want a short piece of string. It's a good analogy for this. Okay, we've got long chain hydrocarbons. But ideally, we want short chain ones. We've got a long piece of string, okay? We want short pieces. What would we do? We would cut the piece of string up into smaller pieces. Well, this is exactly what we are going to do with our hydrocarbon molecules. Okay, we take our large, long chain hydrocarbon molecules and we break them down into smaller and more useful short chain molecules. Okay? Because we've got a lot of long chain, but we want a lot of short chain. Okay, this process is called catalytic cracking. Now, as you can probably imagine from the name, okay, it involves the use of a catalyst. Okay, and the cracking is the idea that we are breaking it up. We're cracking it down from long chains into short chains. Okay. This is an example of something called a thermal decomposition reaction. Now again, we can work out what that means by breaking down the word. Okay, thermal should bring to mind the idea of heat. Okay, and decomposition should bring the idea of breaking something down. So we're breaking down the molecule using heat and also a catalyst. Okay, this can be done in our normal laboratory. Okay, we will do this if we come back to school after Easter. Okay, so we can take our long chain hydrocarbon, okay, and this is normally in the form of an oil. Okay, so we're taking some mineral wool and we're soaking that in oil. That's just so that the oil doesn't go absolutely everywhere. Okay, so this is just to hold the oil all in one place. Okay. Our catalyst is aluminium oxide. Okay. What we're going to do is we're going to heat the mineral wool and aluminium oxide catalyst because, as we've said, this is a thermal decomposition reaction. So we're going to heat it up so that our oil, our long chain hydrocarbon, breaks down into a short chain one, and our catalyst is going to help with that process. Now, as we've seen before, long chain molecules tend to have high boiling points. That's why my long chain hydrocarbon is an oil, it's a liquid. But as I break them down into shorter chains, we know that short chain hydrocarbons have got low boiling points. And so as they break up into shorter chains, they are going to become gases at room temperature because short chains have got low boiling points. That means that the product that we are going to collect is actually going to be a gas. Therefore, the way that we're going to do that, we're going to fill our test tube full of water, okay, and we're going to turn it upside down in the basin. And as the gas is produced, it will flow down the delivery tube up into the test tube, and the water will go down and the gas will be collected. Okay, now if we were to look at our reactant and our product, we've already seen that the oil that we start with is a liquid, whereas the product that we make is a gas. Okay. The smell of them, the reactant has no smell, whereas the product is very smelly. It's very bad smell. Okay, if we were to set fire to them, the reactant would not be flammable at all, whereas the product is quite flammable. Okay, so what conclusions can you make about the reactant and the product? You should be able to make a conclusion about the chain length of the reactant and the chain length of the product based upon the lesson that we did on properties of hydrocarbons, which was either lesson 4 or lesson 5. So if you can't remember, go back and have a look at your notes on the properties of hydrocarbons. Okay, pause the video and fill that in now. Okay, so this is catalytic cracking as it would be done on a small scale in the lab. Okay. However, we wouldn't be able to do this on a big scale if we wanted to produce these short chain hydrocarbons in industry, because it would take too long. Okay, we've only got a little test tube. We'd have to fill millions and millions of test tubes full of gas in order to make it useful. Okay, so this is too small scale to be done in industry. So how do we do it in industry? Well, there are several important steps to this process. Okay, the first thing that needs to be done is our long chain hydrocarbon must be heated. Okay, the reason for that is that we need to vaporize it. We need to turn it into a gas. Okay, we then pass that gas over a catalyst. So we funnel the gas through a tube, and that tube is going to contain lots and lots of catalyst. And we're going to make the vapor go through the tube so that it goes near the catalyst. Okay. And that tube and that catalyst are at high temperatures because, as we've seen, it's a thermal decomposition reaction. This causes the long chain molecules to split apart, okay, and its products are, as we've seen, shorter chain alkanes. Now, there are another product that it produced, which are alkenes. Okay, so there's a difference here, alkanes and alkenes. Okay, you don't know what alkenes are yet. Don't worry about it. We're going to go on to that next week. No, this week, later in the week. Okay, but for now, just be aware that they are also a product of catalytic cracking. Okay, so now go to task 2 and complete the tasks for task 2, then move on to task 3. Okay, as you're going through this work, if you've got any questions, you can post them on Google Classroom. If you've got anything that isn't a burning question, but that you want me to go over in the Zoom meeting that we're going to have this week, which will be on Tuesday, then write it in green at the bottom of your Google Doc. That will help me to get prepared so that I know what everybody's questions are before we start. And if I need to make any PowerPoints or any models, then I can. Okay, thank you very much.